Okay, welcome everybody. It's so great to see all of you here today at NDN to talk about a subject which I think in many ways has sort of been at the top of the news, but in other ways has not received all the attention that we think it should receive, and we're going to talk about that later today. Most of you know us at NDN. I'll just say that we are a think tank that works on a number of issues that we think are a little bit ahead of the curve, and I direct for NDN the Green Project. My name is Michael Moynihan. The Green Project is devoted to the general theme of ushering in or helping to usher in the low-carbon economy, and we have a number of different initiatives there on clean infrastructure. We've begun focusing very much on the electricity network, the internet, and we are delighted today to be talking about the subject of clean transportation, which is in many ways going to be central to all of the other pieces involved in putting together the clean economy that we feel is important to addressing, the three problems of energy independence, climate change, and also restarting this global economy. So we're very fortunate today to have a wonderful panel that's going to talk about different pieces of clean transportation, and I'll just quickly mention who they are, and then I'll give a little bit longer introductions as each person presents. Our first presenter, Kim Hill, is going to talk about fleet conversion, sort of the corporate story, what it means when a fleet converts itself from traditional fuels to alternative fuels. So he's going to be covering that. Then we're very fortunate to have Mike Granoff, who is one of the founders and senior executives of Better Place, the very innovative car company which is putting together transportation solutions in different parts of the world, Israel, Denmark, Australia, the United States, involving an electric car and specifically the infrastructure for that electric car. So he's going to talk about the integration of their business model with the grid and some other very exciting topics. And we also are very lucky to have Kathryn Clay from the Auto Alliance, who's going to talk about different things going on in the American and in the global auto industry that will play a role in creating this sort of clean transportation future. So let me just say a few words on how I see this clean transportation question fitting into the overall structure of creating a low-carbon green economy. Obviously, those of you who follow environmental issues know that this year we've been very much caught up in whether or not the Congress passes an energy bill that might have a cap-and-trade system in it. Currently, the progress on that has been stalled, if you will, by the fact that Congress is still spending most of its time on health care. So we actually don't know exactly what's going to happen with respect to cap-and-trade and sort of that approach to creating a low-carbon future. However, we do know that that regardless of what happens with cap-and-trade, the actual reduction of greenhouse gas emissions is going to occur as a result of the steps being taken by private companies, basically by actors in the economy. The pricing signal is a means to an end, but the end is the actual improvement in emissions. It's the actual substitution of for fossil fuels of alternative fuels. And it also is the jobs that we hope will be created by this new type of energy. Therefore, what folks are doing, the technologies they're implementing, are really going to be key to all this. And as we go forward at NDN with our work on this issue, we're very focused on this, what some people have called the internet, the energy network, and how all the different pieces fit into that energy network. And I'll just mention one example, which actually ties in with what Mike Granoff is going to be talking about, which is the integration of clean transportation in the form of car batteries with the energy network. One of the things that's been holding back renewable fuels, wind and solar and so forth, is lack of storage technology, and car batteries are an ideal vehicle for that. I was thinking today about parallels, and we see a lot of them between the energy network, or internet, and the internet. One of those is that or let's say one of the things which is not similar right now, is that when we talk about most things involving the energy network, we talk about huge economies of scale, huge installations done by specific utilities, for example. As we begin to envision the energy network, which would have some of the same network externalities as the communications network, I think we're going to see more distributed applications, more distributed battery storage, for example. So, for example, on the internet, you would never have all the storage for the network in one place. The storage is distributed all about, and I think we're likely to see that on the energy network as well. So, without any further ado, I want to introduce our first presenter, Kim Hill of the Center of Automotive Research. Kim is the Associate Director of Research within CAR. He is the Director of the Sustainable Transportation and Communities Group, and he has just conducted a study on the economic impact of fleet conversion with one specific case example involving AT&T. I won't say anything more, so Kim, let's hear what you have to say. Thanks.
All right. Thanks, Michael. Is this up, right? Okay, yeah, I'm with the Center for Automotive Research out of Ann Arbor, Michigan. We are an independent nonprofit research organization. We focus obviously on the auto industry, but we have a variety of funding opportunities. And like Michael already mentioned, I wear a number of hats at CAR, and one of them is I'm a director of a group we've recently pulled together for a few of us, the Sustainable Transportation and Communities Group. Sustainability took on a new meaning for me earlier this year, or last year, when two of the big companies that have been mainstays in the industry looked like they might not make it through to 2009 and beyond. So it started calling into question not just sustainability as a big, vague, abstract thing, but really looking at companies that have good technology to move us forward into sustainability. You know, one of the issues that we look at with, from the car perspective, from the car company's perspective, and trying to figure out how do we get new technologies on the road, there's a volatility of fuel prices and volatilities of fuels and volatility of options. And really what we're looking for are clear signals to be relayed from consumers to the manufacturers and to get those to mesh together, these signals, and it gives the opportunity for companies to make the right thing. So as Michael said, I'm here to talk about a case example. We were approached by AT&T earlier this year about doing a study on their conversion of their fleet of vehicles and from normal internal combustion engines to alternative fuel and new technology like some hybrid vehicles. So we use this as a case example. And like I said, this is us, the Center for Automotive Research. The bottom line, just over here in this part, is just so you don't think we're shills for the industry. That's usually the common perception, is that I'm here to talk about GM, Chrysler, Toyota, the like. We get very little research money from the industry itself. We work with government agencies, communities, universities, research institutes, the federal government, labor organizations, other major stakeholders of the international auto industry, and AT&T being one of them. So what was the purpose of our study? One is to estimate the job contributions resulting from their purchase of hybrid passenger vehicles and the compressed natural gas vans, and then to calculate the emissions and energy savings from replacing their standard fleet with these types of things. And one thing that popped out initially was AT&T's doing this now. They started, they actually accelerated the program. One, in light of, I think the recession, is that they just still wanted to pump things through the economy. Two, is that they're awful concerned about a lot of talk about cap and trade, emissions, taxing, or putting a price on carbon. So they wanted to get out there and be a little proactive, and that really appealed to my senses. Let's do the study and see what the data leads us. So they replaced 8,000 domestically produced vans over a 5-year period to compressed natural gas. and 7,100 passenger cars with hybrid vehicles imported and domestic over a 10-year period. Looking at just the jobs, it supports over 1,000 jobs. Actually, it's closer to about 1,170 or so. But not just in motor vehicle manufacturing, but other manufacturing. We know from a lot of studies we've done at CAR that the automobile industry has a huge economic multiplier. It's likely about 6.5 more jobs out in the economy for every one that's in an automotive firm. And they go all over the place: construction, transportation, finance, wholesale trade, professional and technical services. So this is just from AT&T's purchase. These are annual jobs, FTEs. So these 1,000 jobs are going to be in place for the entire length of AT&T's program. So almost 1,200 jobs are generated, $64 million in annual compensation, $10 million in tax revenue. So the 15,000 vehicles that they're buying are roughly, a little over 1,000 every year, and are generating these every single year. And just this one's for the eye test for you, but basically what they're going to do, the end result will be the same as taking 38,000 cars off the road over 10 years for their program. It'll take 211,000 tons of CO2 emissions out. It'll take a reduction of 49 million gallons of gasoline over the 10-year period. And then as it goes onward from there, almost 7 million gallons in tax or in gas savings and 31,000 tons per year, as long as they have these types of vehicles there. So what do we see on this? The market implications on this. Obviously, AT&T, in the big scheme of things, in the size of the fleet that's out there, the private and public sector fleet, is part of that fleet. They're not the whole fleet. The whole fleet, surprisingly enough, accounts for 20% of new vehicle purchases every single year. And this is just the light vehicles, so the cars and the pickup trucks and the vans, not including the big heavy-duty highway trucks and the like. 20% of them, so 2 to 3 million vehicles a year, depending on what the total sales is. If a quarter of these fleet purchases followed the example of AT&T and replaced them with compressed natural gas and hybrids, it'd be equal to taking more than 1.5 million vehicles off the road over that 10-year period, and cut consumption of oil by $15 million annually, and create or preserve 10,000 jobs annually. 10,000 jobs. And we think, really, most importantly, that as we were working on this study and started thinking about what we know about the entire industry, most importantly, I don't know, not most, but equally important, is that fleet purchases can be the catalyst to move and proliferate this high fuel economy technology into the market. They can do it much better than the individual consumers can. Fleets are going to buy them in large quantities. They send a good signal through to the manufacturers that we want to buy hundreds of thousands of these vehicles every year. Manufacturers gear up for that type of thing. Another is there's a high turnover rate in the fleets. The fleets are not just AT&T and other service providers. The fleets are Hertz and Avis and the like. These folks keep their cars for a couple of years and they put them onto the used car market and get new ones. So they're turning over very quickly, enter the used car market. So two things are happening. In the 250 million vehicles that are on the road in the United States are turned over at a higher rate if you're replacing if you're pumping new technology into that segment every 3 to 5 years. If there's a turnover like that, compared to consumers who are keeping their cars 9 or 10 years now. So it takes a long time for an individual consumer to get new technology into their hands. And then also what this will do, because of the large numbers, sending the correct signals to the manufacturers, that they become more affordable to individuals like yourselves. And we all know, if you're looking at a hybrid vehicle right now, that the hybrid version of that vehicle can sometimes cost $5,000 to $10,000 more than the normal internal combustion engine version of that vehicle. And that's because all those development costs are being spread out over all of you. So why not spread it over a fleet? And then those costs are amortized. So fleet purchases just will create that critical threshold demand to pull the technology through. make the technology more available, reduce the cost, it'll proliferate. It'll create and retain these green jobs. You know, the green jobs we've termed as folks that are working on green technologies and the like. These are certainly green technologies. And you know, if this is your thing here, it will reduce the U.S. dependency on oil, especially with, you know, compressed with natural gas, as we see recently. We just looked this up the other day. That they're saying there's 80 to 100-year supply of natural gas under the United States. They've found some new ways to drill for it, and so that has really gone up. So really, in conclusion, this type of program, and like I said, we see it as a case example. It's a great thing to try to promote to other fleets through whatever means possible. Certainly there's a lot of stimulus, there's a lot of subsidy money, there's a lot of things that are being thrown at technologies. We think that the case example we used here for the hybrids and the compressed natural gas are technologies that should be encouraged. There's corporate benefits to this. So from the individual corporation that does it, like we show in the AT&T study, which will be available on our website, the cost savings and the fuel savings to the manufacturer if emissions, or I'm sorry, to AT&T, if the emissions then have a cost associated with them in the near future, your reduction of emissions is going to save you money. The next benefit is a company like AT&T is a service provider to a lot of other corporations. So as corporations are looking to cut their corporate-wide emissions, and they make a decision to hire a company that is using you know, this type of technology in its fleet versus the other company who maybe isn't, they can just add to that process some indirect benefits. We call it the process chain. This is a huge, everything that's involved in making a final product. Domestic natural gas supplies are high. Technology flexibility, we think, is the key for the private sector. We're seeing a lot of money being thrown at some things right now. I come from Michigan, and we're swimming in it. We're not sure that we should be picking any one specific technology. We need a buffet of technologies to be incentivized. We need a target, and I'm saying we collectively, all of us, because we want those manufacturers to make the cars and vehicles that we want. So there needs to be a strong signal that we're trying to get to a goal of reduced emissions, higher fuel economy. There has to be some options of getting there. Can't pour all your money into one basket because, frankly, that hasn't worked yet, unless somebody wants to point out something that it has. We think AT&T is a great case example to change corporate behavior, and most importantly, really to provide a template. And I think AT&T would second this, to provide a template for real change. And you know, like I said, I encourage any means possible to any of the fleets to take this kind of approach and to move forward. So with that, that's basically, I'm going to wrap that up, and I look forward to the other folks on the panel. Thank you.
Thank you very much, Kim. This has been an incredibly climactic year for the auto industry, both good and bad. I guess under the bad category would be essentially the bankruptcy filings that had to be filed by both Chrysler and General Motors. On the good side is the fact that both of those companies emerged relatively rapidly from the bankruptcies. Another good thing that I think we can point to is the success of the Cash for Clunkers program this year, which I saw, according to one study, actually raised overall mileage of vehicles purchased by 1 gallon relative to what it would have been otherwise during the period of the program. But perhaps the greatest positive thing that may hopefully come out of this transformation is the creation of entirely new companies and new ways of looking at transportation. And one of those is certainly Better Place. So we're very fortunate to have Michael Granoff to talk about Better Place and also, I guess, more generally about the auto industry. Michael is head of oil independence policies for the company. Better Place is a Palo Alto-based firm that, as I mentioned, has operations in different countries around the world. Michael is also the founder of Moynihan Energy Capital, and I believe that Moynihan was one of the founding investors in Better Place. So look forward to hearing about what Better Place is up to. Thanks, Michael.
Thank you, Michael. One of the things Michael didn't mention is that I also have been associated with NDN since its creation in '96, yes. And I've always enjoyed that association because I really find that it promotes pragmatic and real solutions and tries to separate out the politics as much as possible and accomplish things. So it's always a pleasure to be able to talk to an NDN audience. Few things. First of all, there are two separate problems here when you talk about cars and so-called energy independence. And too often they're conflated. They're both problems and they both have solutions, and the solutions are very related. But we should separate them out. And that is to say that we don't have, and by the way, as far as the slides go, I'm going to, at the end of my talk, I'll run through some pictures. But primarily, I'm going to speak without the slides. We don't really have an energy independence problem because we don't really import any of our electricity. What we have is an oil independence problem, which is that we depend for 99% of our transportation needs on oil, and we're importing close to 70% of that oil today. And that's where Better Place is focused. And as I go through later on, I'll describe how this dovetails with the other issue that we're trying to solve, which is the carbon problem, which is not helped by the fact that we are energy independent for electricity because of all of the use of coal and other carbon-emitting forms of electricity. But the founding question for Better Place was actually, how do you run a country without oil? And that was and there were three criteria that our founder, Shai Agassi, set when he set out to answer that question. He said it had to be something that was driven by the market, not by an edict, which obviously wouldn't work, wouldn't be sustainable. It had to be scalable. So it had to be something that actually could go to be adopted by everybody. And it had to not involve new science, new experiments, new technologies that might come out sometime in the future, because that's really the way that we've dealt with this problem for the last 40 or 50 years. We've said, well, we're just a few years away from hydrogen, or a few years away from the magical cellulosic ethanol that is going to solve all of our oil dependence problems. So with that set of criteria, what Shai discovered was that the only thing that actually met them was electrification. So the question is, how do you move to electrification of transportation? And here the thesis was, if you could create a car that was more convenient than what people are accustomed to today, and you could make that car less expensive, then people would choose that car and they would pay the same thing that they're paying now on an ongoing operating basis. So how do you make an electric car more convenient than people's experience today? And the answer is in infrastructure. The answer is in extending the electricity grid, which Michael's doing so much interesting work on, and extending that to the parking lot, to the place where your car sleeps, where your car is when you're working, when you're at retail, when you're downtown. Wherever your car is, you should have the ability to plug it in. If you did that, with today's technology, every time you came back to your car, you'd have a 100-mile range. It's like you were being followed around, you got a contract with Chevron, and there's a guy who comes and tops you off every time you park. So that actually makes it more convenient, because 90+% of the time, you're not going to go 100 miles in your next leg. So you never have to stop for your energy. You're just plugging the car as you get out. I do that today. I'm lucky enough to be part of a program run by Mini. That's a one-year experimental lease for consumers on all-electric Mini. And that's been my experience for the last 4 months driving that car. I haven't been to a gas station. The second part of it is, what if you want to go the 100-plus mile trip? You want to drive from here to New York. And we had to answer that question, because even though it is the exceptional trip, people aren't going to buy a car without that ability. So the answer to that is, what's the fastest way to get the electrons necessary into the car? And what we discovered is the best way to do that is actually by switching out the whole battery. By pulling into a station and robotically having the depleted battery come out, get recharged for a future car, and have a ready, fully charged battery get put into the car. We were told that this couldn't be done, but we found some engineers who were up to the task, and in fact, earlier this year in Japan, with the Japanese government's money, we demonstrated that it could be done. I don't have the video here, but it takes about 45, 50 seconds to watch on our website at betterplace.com if you're interested in seeing it. And now we're engaged in another program in Japan where we'll be demonstrating how this works in taxi cabs going between downtown and the airport early next year. The other interesting thing, because the other thing we had to do was figure out how you make the electric car less expensive for consumers. As you know, electric cars today are at a big premium. And the answer to that is most of the excess cost comes from the battery. So if we're switching the battery out, we have to figure out what the nature of that battery is. And the nature of that battery is the critical question, because it's been seen until now as a component of the car. But what in fact it is economically it's the equivalent of crude oil. It's a consumable. It's something that each time you drive, you use a little bit of it. And so it's really naturally part of the energy infrastructure. So Better Place actually buys all of the batteries and buys the electricity, sets up the infrastructure, and then sells miles to consumers. We've been analogized a lot to cell phone companies where they put infrastructure and you buy minutes from them. And that's not a bad analogy, but what we found recently is that we're actually closer to what people are used to today, because people are used to paying a certain amount for a car and then paying an operating cost every week or every few weeks. So to pay a monthly fee for your miles is really what people are accustomed to doing today. When you go to the gas station, you're really buying your next 300 miles. It's like a prepaid calling card in that sense. And we'll have different programs by which people can buy miles, including the Metro PCS plan, buy all the miles, pay one fee and drive all the miles that you want. And so we're setting up this infrastructure today in Israel and in Denmark, soon to be setting up in Australia, and we've made announcements also in the Bay Area of California and Hawaii, which we are working on a strategy to execute on. We also have a car-making partner in this, which is Renault. We actually announced last month in Frankfurt that we've signed a contract with Renault to buy 100,000 battery switch sedans, and they debuted this sedan. They're midway through their 4-year production cycle, and they demonstrated it in Frankfurt. It's a 5-passenger luxury sedan, and it will be in the market in Israel and Denmark 2 years from now, in 2011. It's the first time, it's the largest order ever placed, as far as we know, for a non-gas consuming vehicle. And so we're very proud of that. And really, 2 years ago when we started talking about this, if we were effectively competing against other alternatives to oil, hydrogen, biofuels, and so forth. Today, what we're finding is that there is a general consensus in the industry, among governments, that electrification is primarily the future. And what we're competing against is different modes of range extension. If you read about the Chevy Volt, the concept there is that the way that you extend the range when you have to go on a longer trip is you keep an engine in the trunk that charges the battery. And there are other programs that believe in fast charge, which is that there'll be infrastructure where you can plug in for a half an hour and get about 70 miles. We think that battery switch is the best mode of range extension, and separation of the battery for the ownership purposes is what will economically make the car less expensive and will encourage mass adoption. And so that's what we're going with. But it's interesting how this evolution has taken place very quickly towards electrification as a solution. One of the big concerns that I have personally, as I see these policies get set around the world, is that the U.S. is lagging. We start with an internal disadvantage, which is that when Better Place is selling our miles, the competing product is gasoline. And as you know, gasoline is cheaper in the U.S. than almost anywhere else. So in Israel, for example, the average consumer is paying between 30 and 40 cents for each mile, depending on the efficiency of the car, the price of gas exactly at that time. In the U.S., we're paying about a third of that. Our costs, by the way, are about 8 cents a mile on electric. It's about 6 cents on battery depreciation and 2 cents of electricity. And as the batteries have longer lives, as we're seeing they do each cycle, the 8 cents goes down over time. But for the U.S., because it's less attractive from a margin point of view, there's less incentive for private companies to come and build the infrastructure here. And that's why it's easier to do it elsewhere. It's why we're starting in countries that have high gas prices. And that's a problem that really we need policy to fix. Obviously, everyone thinks of gas tax, but we all know that that's not something that's in the offing. And in fact, it's probably not even the best way to approach it. If we had more time, it might be. But we think that reducing the cost of capital on all elements of the solution is what needs to be done. And it's been done to some extent. You need three elements. You need, I call them A, B, and C: automobiles, batteries, and charge network. So we've put money out there for the car companies to switch to advanced technology vehicles, and some of that has already been accessed. We've also put a lot of money out there for U.S. battery manufacturers to stand up in the U.S., and the good news is that in Michigan there will be millions of batteries coming off assembly lines in 2 or 3 years. But the question is, where are those batteries going to go? And my fear right now is that they're not going to go into cars that are made in America, and they're not going to stay in America. They're going to go to Europe to displace much more expensive gasoline. And part of the reason, the major reason, I think, is because we haven't yet focused on the third element, the C, which is the charge network. You need to have that infrastructure in place if you're going to give consumers the peace of mind that they're going to be able to have a seamless experience in an electric car. There's been a certain number of consumers, it's actually a fairly large number, I think, where there's a lot of pent-up demand, and the competition to get into this mini program was fierce. I'm sure as the first electric cars come on, they'll get gobbled up by early adopters. But we're talking about mass adoption, and people wouldn't buy a cell phone if there wasn't towers to support it. They wouldn't buy gas cars if there weren't gas stations, and we need to put that infrastructure in place, and the government really has to help, particularly if the U.S. is going to compete in what we think is going to be the biggest industry in the 21st century, which is the combination of cars and the infrastructure for the cars. And finally, we're talking about the grid, we're talking about renewables, and how does it all fit into that? First of all, so no one should think that we are simply moving emissions from the tailpipe to the smokestack. Better Place is publicly committed to signing long-term power purchase agreements with utilities to buy renewable electricity, even at a premium. And we're able to do that because of the margins that I described. But more than that, if you look at Denmark, for example, where they get a huge proportion of their electricity from wind, more than any other country, they still are leaving a lot on the table. The reason is they get their wind at night when there isn't demand, and they don't have the ability to store it, so they pay the Germans to take those wind electrons off their hands. When the Better Place network is in place, and these cars are plugged on average 22 hours a day, almost all of them plugged overnight, what you end up with is a network that can accept those wind electrons overnight and can essentially TiVo the electrons, so they can then call on them during the day. And car batteries are the natural marriage for wind or for solar or any intermittent electricity, because you need them to drive the cars anyway, and once they're out there in mass numbers and connected to this network that we're building with a control center, they can be the storage for those intermittent electrons, we think, causing a massive stimulus in private investment in those types of electricity sources. So we see an opportunity for the U.S. really in creating jobs through building out this infrastructure, in revitalizing the car industry, in ending our dependence on oil, and in reducing carbon by a huge amount by taking the tailpipes off the road and by creating this storage for clean electrons. So we think that this could be, one of the most exciting projects for the next few years, and we hope to work with the U.S. to see it happen in a way that, in a size that's commensurate with the opportunity. I'll just run through a few pictures for you now. Essentially, what you're looking at here is the old infrastructure for cars and what we think will be the new one, with the renewable electricity, the charge spots, the battery switch, and the consumer aspect, which enables the consumer to know all the information about their car and its energy situation. This is effectively what the integrated solution looks like. And here's a close-up on our charge spot, which actually has already won an industrial design award. We have about 1,000 of these already on the streets and parking lots of Israel. Those are being tested, and we'll have next year going to 100,000 before the first cars arrive in 2011. And here are some examples where you can see it's in parking lots. This is a street in Jerusalem. This is a parking garage and a home garage. This is one image of a battery switch station. As I said, you can watch the video, which is pretty fascinating, on our website. Here's some concepts of where you could actually put the battery switch. Gas stations are a natural that everybody thinks about, but you can actually put them in urban parking garages. You can put them in a cab line outside a hotel or in an airport. And we think that's what's going to happen. They're not a very large footprint. And then there's the integrated consumer end of this that you integrate your navigation with your energy services with customer support that's always there, so that the consumer always never has range anxiety. They always know where they're going to be able to charge the car, if they're not going to get to a charge spot in time, where they can switch the battery, and how to get there. So that's effectively what solution looks like. Here are the countries that we're operating in, and looking forward to conversation later on.
Thank you, Mike. That is just fascinating, and it's an example of the innovation that is ultimately going to solve this problem. Just fascinating stuff. So we're now going to hear from our third presenter, Kathryn Clay, who is the Director of Research for the Alliance of Automobile Manufacturers. She is an expert on the whole gamut of auto issues, and will talk to us a little bit about what's going on in the auto industry as a whole.
Hi, everyone. I'm Kathryn Clay, Director of Research for the Alliance of Automobile Manufacturers. It's a pleasure to be with you this afternoon. Let me first point out that I have brought with me some literature about the Alliance. The Alliance is a trade association representing 11 major automobile manufacturers, and this is what we call our playbook. This has a listing of our policy positions on all of the topics that we've touched on today in the panel, on energy security and climate change, also talking about safety and some of the issues you heard about in the news recently, for example, on distracted driving. So if you're interested in the Alliance and would like to know more about our policy positions, I'd encourage you to pick up one of these in the back. And there we are. I am really pleased to be able to be part of this panel, because as I was sitting and listening to the previous speakers, it occurred to me that what we're really talking about today is twofold. We're talking about innovation and about looking for ways to find opportunities to make a business case for innovation. And as our moderator pointed out, this is really a point of transition for the auto industry as a whole, and I would even argue for the transportation sector more broadly. We're looking at ways that we can solve our twin challenges of energy security and promoting environmental protection, and that means both local and global aspects of the environmental protection issue. There are ways that we can approach both of those simultaneously. And the third leg of that triangle that we need to keep in mind is that transportation remains a cornerstone of a strong and vibrant economy. And the auto industry is still an intrinsic part of that. So that threefold challenge that we have before us of energy security, environmental protection, and promoting the transport of goods and of people is really what we mean when we talk about sustainable mobility. Now, let's talk a little bit about climate change in particular. This is our CEO, Dave McCurdy, and Dave has said that climate change, a solution to global climate change, will not be found without strong, bold U.S. leadership. The Obama administration has led the way, bringing stakeholders together in a constructive and open dialogue. And as a stakeholder in this process, the auto industry is at the leading edge of our national transition to a low-carbon economy. Now, the real moment when we saw this occur, that threshold moment, was May 19th, when in front of the White House at the Rose Garden, the president, along with the CEOs of many of our member companies, stood for the announcement of a new Obama national standard. So this standard, for the first time, joins together the CAFE requirement and, for the first time, an explicit greenhouse gas emission requirement. So the auto industry is really the first sector to have an explicit greenhouse gas target. And that means that for the first time, part of our economy is facing the reality of being a carbon-constrained world. This graph shows how very dynamically challenging this new Obama national standard will be. So the three lines that you see here are the pre-2007 or pre-Energy Independence and Security Act standard, and that's just for cars. So that's that gray line you see at the bottom. You can see that even the 2007 requirements for an increase in CAFE were extremely challenging and very ambitious. That took us through to 2020 and went to 35 miles per gallon. In itself, an extremely challenging goal for the industry. Now, what was agreed to in May with this new administration is an even more daunting ramp-up of that goal, so an even greater challenge to the industry, which the industry is committed to and poised to meet. And that has moved that standard up to 2016. What this ramp-up means, and this is only the incremental difference between our previous high standard from 2007 until the 2009 announcement, will be an additional reduction in oil consumption of 1.8 billion barrels over that time frame, and lowering greenhouse gas emissions by over 900 million metric tons. I put this up there to give you some sense of context of the degree of commitment that the auto industry has brought to these twin issues of energy security and global climate change, and just how significant and how challenging these technical goals are. This really speaks to this moment of transition that we're at, and the degree to which the auto industry has internalized its responsibility to be part of that solution. Meeting these challenges is going to mean a great deal of innovation. So as we spoke about a moment ago, it's about innovation, and it's finding the business cases to support that innovation. We have today on sale and models available to consumers over 50 technologies that will reduce emissions, increase mileage, and allow vehicles to run on clean fuels. But having said that, and I think underscoring the fact that we have 50 of these technologies on the market today and more coming with every model year, there is no silver bullet or any single vehicle technology that will completely deliver sustainable mobility. And while we need to keep our vision on long-term solutions like full electric vehicles, plug-in hybrids, hydrogen vehicles, the whole suite of technologies that will be available over the decades to come, we have to remember that there are also near-term technologies that can improve the fuel economy of vehicles, turbocharging, downsizing the engines while providing the same performance. Those kind of technologies can take the internal combustion engine much farther. There's a lot of room for improvement even in today's technology, and I think it's important that as we have our eyes on the goal of long-term emissions, even out to the 2050 timeframe, we have to also remember that these near-term technologies can deliver the benefits that we need to make that path towards a lower carbon future possible and bring that timeline forward for bringing those real reductions today. I like this graph because it gives a sense of the timeline that is required to bring new technologies to market. So it's a daunting prospect for automobile manufacturers. It takes years and years of commitment, a great deal of investment. The typical powertrain for a new powertrain requires $1 billion of investment and 5 to 7 years to bring online. And that does not even include the very early stages of research that are required before full-fledged powertrain development can occur. The other part, the second half of this graph, shows you that even after the investment has been made and the early commercialization for those early adopters has come on, we need to bear in mind that it takes a great deal of time for the fleet to turn over, for consumers to adopt those new technologies, and for the technologies that are at first available only in 1 or 2 or 3 models to proliferate through the fleet. And that's why you see new vehicle sales and total fleet penetration shaping that S-curve, because it takes a while before you even reach that tipping point where you're really going from the early adopter phase of the technology to the full-fledged massive market adoption. This is another important point that I think is important to bring into our dialogue. Many of you have seen the McKinsey curve that shows, usually it's a one-dimensional representation, that shows above a center line energy-efficient technologies which have a payback period and are, in a sense, negative cost, because the energy savings over time pay for the investment in that technology up front. Where things that have a positive cost would be things like investing in fuel switching at power plants. That's something that's done if there is a cost for carbon, but in a no-regret strategy, are not sufficient to pay for the technology investment. There's another dimension to this that's important to bring out for our industry. And while the industry has made that commitment to greenhouse gas reductions, we think it's important to also remember that there are capital-intensive requirements that vary from industry to industry. And the automobile industry, it turns out, is according to the McKinsey study, one of the most capital-intensive in terms of making those capital investments to switch over to more carbon reductions. So in fact, if you compare that green dot there, which represents the capital investment to making the investment in new production facilities for the lower emission vehicles, compared to what you see on your far left of the chart, the capital intensiveness of passenger vehicle production is actually 10 times that of power generation. So there are two dimensions to it, and as we look at where, as a society, we have limited capital, we believe that the auto industry has a very significant role to play, but if we're going to be serious about our goals of reducing carbon throughout the economy, we need to bear in mind that there are other sectors that we need to bring into the fold as well. Automakers are profoundly linked to our consumers, and this comes again back to our statement of the business case. What's crucial about consumer engagement and for creating partnerships between the auto industry and our consumers is creating the price signals and the right market signals that bring consumers along. It's not enough for the auto industry to produce the technologies that can produce, in theory, the carbon abatements that we all desire. We have to also make sure that those technologies make it to the hands of consumers and that those are actually the vehicles logging the miles on our roadways and our highways. To accomplish that, government policy to send consumers appropriate price signals can address many factors of consumer behavior that, in a holistic sense, affect the emissions from the transportation sector. So consumer choice can affect not just the choice of vehicle and the fuel economy that that vehicle is able to provide, but also the number of vehicle miles traveled, whether consumers choose to use eco-driving practices, which are simple practices that any consumer can use to multiply to maximize the effects of the fuel economy potential of their vehicles. Also to encourage consumers to use other options such as carpooling or public transport. And importantly, to bring back to our earlier graph, the right kind of price signals can be very crucial to leveraging higher adoption rates for new technologies for vehicles. Unfortunately, our public policy today has a real disconnect between our gas prices and the fuel economy incentives or the fuel economy goals that we put forward for our national policy. So we have an energy policy that says automakers are mandated to manufacture more fuel-efficient vehicles. At the same time, we promote a policy of cheap gas, and we find it difficult to put forward a political message that says to consumers, more expensive gas is actually part of the solution of driving the behavior for us all to make the choices that we need to make to bring these more advanced technology vehicles into consumer hands. Now, even the recent legislation that was very forward-looking on this very point, the Waxman-Markey bill that was passed in the House, an EPA analysis of that said that even that very forward-looking bill does not go far enough when it comes to gas prices. 13 cents in 2020, projected to 69 cents in 2050. And we know from recent experience that these kind of cost increments are not significant enough to drive the kind of consumer choices that we need to really draw these vehicles into the fleet. What we really need are sound public policies to send consumers consistent market goals that will promote fuel efficiency and help us meet those goals of energy security and reductions in greenhouse gas emissions. We've actually run this experiment. Just over a year ago, in the summer of 2008, when gas prices approached and then exceeded $4 a gallon, we saw an immediate consumer response. This graph shows what happened to vehicle miles traveled nationwide when gas prices approached $4 a gallon. So you can see this is June of each year for consistency, since driving patterns vary through the year. And what we've shown here is the figures for June of 2005 through 2008. So now, could also have included 2009, where you'd see a rebound here as people have begun to drive more, as gas prices have gone up or have gone down again. But what you see here was that there was an almost instantaneous response by consumers, that when we hit $4 a gallon, something really, really dramatic happened. And we saw an almost 10 billion mile drop for the month of June in 2008, year on year from the previous. 10 billion miles is significant, and that adds up to a lot of greenhouse gas emissions and a lot of gas savings. One policy option that has been discussed, there have been mentions of this by folks such as Thomas Friedman. Various op-eds have been written in publications such as the New York Times and Washington Post on this issue. And that is the idea of setting a gas price floor. Now, the advantage of a gas price floor would be twofold. It would give consumers confidence when they put the extra increment of funding forward to buy that new vehicle, that advanced technology vehicle, that they would know that they would get their money back over the lifetime of their ownership, because they would have that certainty that the fuel savings that would accrue to them would compensate them for the incremental cost of that advanced technology up front. The other important thing that a gas price floor could accomplish would be certainty to investors and to venture capitalists and others that are trying to make advanced technology investments work. So to know with certainty what was going to be the competition, right? What kind of fuel price do we need to be able to compete with, whether it's advanced biofuels, whether it's batteries. That kind of certainty could do a lot to drive investment in alternative technology vehicles. So to sum up, the government, all levels of government and the auto industry have been working together in a new way at this time of transition. There's been a new sense of partnership and a new kind of open dialogue between the government, the auto industry, and other key stakeholders. And we need to continue in this very open and constructive dialogue going forward. Our common dialogue should recognize that we need a strong and competitive auto industry, because at heart we need that strong industry to be able to develop the key technologies that we'll need going forward. We need to continue to seek opportunities to empower drivers and to give them the market signals and the price signals that they need to make the choices that will improve all of us and produce those societal benefits. And we need to embrace public policies that promote a diverse range of technologies, since we can't know going forward which technology in the end will yield the greatest societal benefits. It's in all of our interest to continue to invest in a broad suite of these technologies. And with that, I thank you and look forward to questions.
Thank you very much, Dr. Clay. That was extremely interesting. And I think between our three panelists, we've really seen that there are very different ways, each of them, with its own strengths in terms of addressing these challenges that we face. For example, the fleet conversion is often a voluntary thing that corporations can take right now, right today. And as Mike Granoff was saying, the whole idea of what Better Place is doing is to take technology that works today and create the right business incentives so that it succeeds in the marketplace. And in turn, I think we've seen with Dr. Clay's presentation that in many ways some of the important policy decisions already exist in the form of fuel standards. So this industry that we're talking about, transportation, is probably the most carbon regulated and carbon constrained sector out there. So when we talk about, for example, putting a price on carbon, this is a sector that already has a price on carbon to a degree, and the type of prices or price signals that we're talking about adding or changing may not actually be sufficient to make things happen. So these are all very interesting ideas, and let's open it up now and take questions from the audience. So why don't we start right here?
I'd like to address all three
Yes.
quickly, please. I think Better Place is a great, and I commend you for going outside the United States. I really do, and I think you're going to do well. But I'll come back to Kathryn in a minute. Kim, in your organization, I know well, I know David Cole, you do great work. I'd make one suggestion in your numbers, is to put the cost of the hybrid in one vehicle and make the conversion of the fuel savings. I have a hybrid. I can't buy the hybrid for fuel savings.
Right.
So I think it would still be, there's some big numbers of savings up there, but if you took one vehicle, whether it's $8,000 over the gasoline engine, and then compute the numbers, I think it would help the audience understand those numbers
Sure.
better. So that's, but you do good work. Kathryn, you're from Southfield? Oh, no, I'm here in Washington. Okay, wasn't the Alliance in Southfield?
We do have an office in Southfield.
Right, and you're part of ILSAC. You're part of the Alliance, the ILSAC, which is the U.S. car manufacturers and the Japanese.
Oh, yes, so we have 11 members, the Detroit companies.
I have a
and-
message for you
Yes.
particularly. I believe that the automobile current power plant is going to be here for quite a while. The problem is that there's fuel efficiency to gain by altering the phosphorus level in the motor oil. The problem is that the phosphorus level is pro-friction, and the industry that you represent very well understands that. It's the food chain that supplies the automakers that don't want it. That's why I come to Washington, because API sets the standard on phosphorus level. And as long as it stays up to the 600 to 800 parts per million, the power plant that you want to see stay is going to be under pressure. The answer is not in the fuel. They've taken enough technology out of the fuel. It's in the motor oil.
So if I could just respond quickly, I'd love to follow up with you afterwards as well. In the interest of time, oh, no, absolutely, but I just want to say briefly that there are other fuel components that we're looking at. We've just released a major study on the effects of sulfur and advocating for even lower sulfur levels, ultra-low sulfur levels that would enable the entrance into the U.S. market of even more fuel-efficient technology such as lean burn engines for gasoline engines. So critical issue. Yeah, and I think what you're saying just speaks to this very important point of the vehicles and the fuels being a system. And I'd love to talk more with you.
Could I also respond for a moment?
Yes,
You made a great point about the individual and buying the hybrid vehicle, and that was the point of that the fleet is going to drive it, because an individual consumer doesn't get the right price signal. And the fleet can go out there and write it off as a business expense when they buy a vehicle, and they can get the fuel economy savings, which granted aren't enough to go out and buy 1,000 of these.
Is there kind of an economies of scale issue if you buy 1,000 vehicles? Does it work out a little better than if you buy one in terms, or is it?
If you're buying from a manufacturer, they sure do give you
Okay.
economies of scale, but it's still, it may not be enough. But the anticipation on this study was that there would be an extra charge on top of carbon release, and from a corporate perspective, and the way to move a lot of vehicles and then drive the price down so that you as an individual. Yeah, sure. I only had 10 minutes. Sorry. There's a lot of things I could say. Yeah, thanks.
Right here?
Hi, I have a question about the new fuel standards. How do you think electric cars fare under those new standards? And I have 2 points on that. I understand that the EPA has said the credits automakers receive for doing electric technology will be really reevaluated in 2016 because of the fast evolution of the technology. And then also, some people have concerns about how the standards they only factor in the tailpipe emissions. So electric cars, while they don't have any tailpipe emissions, they still get their electricity from coal plants and whatnot. And so a lot of people say that that doesn't accurately factor in electric cars' emissions. So can you comment on that?
Who would like to take that? Okay.
Okay. Well, I think there are a couple questions there. Let me try to address both halves as I heard them. The first is concern over how fuel economy standards treat electric vehicles. And my understanding is that that's ongoing work being done by EPA and also by the Society of Automotive Engineers. So you correctly raised the heart of the question in the second part. So the first part is that work is underway. And my understanding at the moment is that they are looking at it without regard to the source of the electricity. Okay, so that's at the moment. You correctly raised the point that technology is evolving very quickly. The issues are evolving quickly. The second part of your question, I think, underscores the importance of having an economy-wide program for carbon. If we have an economy-wide program for carbon that captures those emissions at the source of the power plant, it obviates the need to include those in the tailpipe standards. I think that's the most elegant solution. I think that when you end up having double regulation on an industry, you end up having unintended consequences. I think there are very few people that would want to have a situation where this emerging and promising technology of electric vehicles had a double burden in a regulatory sense that made it more difficult for people to enter into those markets. But I think it's an evolving issue that we need to be communicating with policymakers, and it underscores the need to have an economy-wide approach. A cap-and-trade program would certainly qualify. A carbon tax, honestly, would qualify.
The front row? Yeah. Sir, yeah.
This question is for Micah. You talked about the infrastructure as being a problem when it comes to electrification and the grid, and I agree with you. I think one of the things that is holding back a lot of the consumers, obviously, is where do you get the power from? And folks who live in apartment complexes don't necessarily have access to a power grid necessarily.
It's a long extension cord from 16F.
Exactly.
Lexington
Who
Ave.
pays for it, who's going to get charged, and so forth. They can quibble about that later on. But you mentioned about the gas stations, and I think that would be the most natural fit for something like this, especially since oil is not infinite. It will eventually run out over time. And I would think that with the current profit margins that they're working on right now, they could invest a portion of that to converting some of their gas stations to a multiple dual-mode system. Are the oil companies getting involved in this project that you're currently working with, or has there been a lot of resistance to what you're trying to do?
Neither. We haven't seen them get involved. We haven't seen a lot of resistance from them. I think you raised a very interesting point, which is at the same time as we've seen the auto industry go through these death throes these last couple of years, the most profitable industry in the world continues to be oil. And there's something unnatural about this imbalance. And it's something that I think a business model like ours could help bring back into line, put the proper incentives in place so that we can have a thriving auto industry again and have the power that runs those cars be domestic, clean, and less expensive. In terms of the infrastructure and gas stations, like I said, gas stations are a natural place to put battery switch stations, but what makes it truly convenient for the customer, what makes it a better experience, is to not have to stop for energy when you're not going on an extended trip. And that means being able to extend the electricity grid to wherever your car parks. And that's what we're doing in Israel and Denmark and elsewhere, is to put those charge spots that I showed in garages, whether they be personal residential garages or urban large public garages on streets and wherever your car is spending a significant amount of time, so it can get refueled essentially while it's sitting there anyway, and also act to do services for the grid and be storage for renewable electricity.
Yes.
Hopefully this is on topic. But I was just wondering how land use policies or land use factors into your carbon reduction strategies in the sense of higher density versus lower density, promoting more options to driving, and how that would affect the infrastructure for electricity, because in rural America it might be more difficult to provide that sort of electricity infrastructure, and just if you could, anyone could speak to kind of that issue and how that might affect your policies.
I can speak to that a little bit. I think that there's no question that in the early stages of rolling out the network, the infrastructure for charging, there probably are advantages to density because you have more cars in a constrained area. But in a way, something similar happened with electrification, which is initially it was rolled out in New York City and downtown Manhattan at the Pearl Street station. For a long period of time, electricity was only available in cities, and it really took the electrification initiatives during the Depression of the Roosevelt administration, TVA and rural electrification and so on, to bring it to the rural, basically universal coverage. And eventually, I mean, once that was done, people were amazed at how it actually worked. And so I think, you know, as this is built out, as with cell phones and some of the other analogies that have been mentioned, you will see certain coverage areas, but eventually you'll get to 100% coverage. So, and you see that with gasoline, actually. It can be harder to find a gas station in some of the remote areas, and people have to plan ahead. Yes, in the back row.
Question for Michael, Better Place. You mentioned the battery switch. Is it an automated process? Is it so there's no person sitting below the ground that's switching out the batteries? It's a fairly quick.
Yeah, you know, I hosted a governor in our research and development headquarters in Israel a number of months ago, and I was standing behind him, and our R&D person was demonstrating how it worked. This was before we had the video of the actual process, and he was bragging about how it required no human intervention whatsoever, and I was kind of thinking, I knew the governor was looking for jobs. So there are a lot of jobs in building out the infrastructure, but in terms of the switch station itself, it's a fully automated process.
But beyond the battery itself, the vehicles obviously will have to get serviced at some point in time. Where is the servicing of those vehicles done? Is it?
Well, it doesn't have to change from today's model. We're not generally selling cars. We may in certain markets where that are peculiar, but in general, the car companies, we look to them to adopt the notion of battery switch. We think they will because it will make most sense in the long term. But then they can still go ahead and sell the cars and service the cars. They'll actually need less service. Electric cars have many fewer parts and all of that, which also goes to the point of the need for a different way of looking at the business model, perhaps a recurring revenue model for the car makers as well. But you know, we will take responsibility for effectively guaranteeing mobility, which means that if there's any problem with your battery, you can obviously just switch it. If you get stuck because your battery is dead, we'll take you to the next battery switch station and make that happen for you. Everything involving the car itself can stay with the car maker and the dealer network.
Yes.
Kathryn mentioned there's no silver bullet. Hill mentioned there's referred to a buffet of technologies. I like that phrase. With that in mind, what do you attribute the lack of public acceptance of advanced clean diesel in this market when in fact it reduces CO2 emissions 25 to 30% and improves fuel economy? So, you know, I noticed your AT&T example did not test diesel. I was wondering if there was a reason.
The consumer, if anybody was around in the 1980s, General Motors rolled out a number of cars with diesel in them, and they were horrible. They didn't work up in Michigan very well. You know, starting them in cold climates, they were stinky. Anybody who's driving around any of these old Volvos or Mercedes, my opinion is you ought to get those off the road right now. But if you're behind one of those, there's a lot of smoke coming from them. And so I think the perception problem is the problem. The same as the perception problem is for the, you know, we've segregated the industry into the, you know, the old guard, the Detroit 3 automakers, and the new internationals with the shiny brand new things. The perception on quality and the like is so dramatically different when you segregate like that, and the reality is nowhere near that. So the perception on diesel, I agree with you 100% that the emissions are a lot less and the fuel economy is about 25 to 30% more. Why AT&T didn't mention that, it's probably the unavailability of it on the small cars. If they were doing medium duty or large duty vehicles and offered that option, we would have brought that up. But so you know, it's all over in Europe. Somebody was talking about tax policy and the price of gasoline in Europe. The gasoline is taxed at a much higher rate than diesel fuel is. So what do you see in Europe? You see about a 50% or more saturation of diesel vehicles, even very small ones, driving around in the streets. Because people do that equation, do the math.
Yes.
This is a question for Mike. This is probably down the road a little bit, but have you thought about the impact on gasoline taxes? My understanding in the U.S. is that gasoline taxes pay for transportation systems, basically. So sooner or later there'll be a cross impact in terms of if we reduce gasoline taxes and building the highways. What are your thoughts on that?
Well, that's already a problem, because the gas tax hasn't been raised in so long, and in real terms, it's declined significantly, and the Highway Trust Fund is, not doing so well, from what I understand. We expect to be taxed. We don't expect a free ride here, and if this industry is the future as we expect it will be, then it'll actually be a much more elegant way of taxing, because you not only will have the ability for the federal government to say, okay, it's going to be a penny a mile, which would actually be a little bit more than revenue than they're getting today. But you can also have all sorts of different programs where congestion pricing, for example, would not require any additional infrastructure. When you're going in a certain direction towards an urban area, it could appear on your screen, okay, if you want to go downtown today, the price is going to be as follows, and it'll just get charged to you right along with your energy cost. So taxation becomes easy, and I'm sure at some point we'll get aggravated about it, but we actually look forward right now to being taxed.
You've got to make sure that it's indexed to inflation and not to have the Congress vote on it during your
Okay, I think we have time for one more question. Would anyone like to ask another last question? Yeah. Oh, sir?
Thanks. I have a question about Better Place infrastructure again. Now, it seems to me that the difference between the cell phone and electricity rollout earlier last century was that they were bringing a service to people that they didn't already have. So so it seems like I can see it working in Hawaii, pretty smaller, or like even Israel, where it's essentially an island. But how do you see it rolling out in the U.S. or larger countries? I mean, is there a vision for that in terms of, it seems like it would be just extremely capital intensive to make that happen.
Well, it's funny. Every audience I speak to, I generally find that there's one guy who's absolutely certain the next day he's got to drive to San Francisco. And he's not sure why. It's never happened before, but tomorrow morning he's going to get a call. He can't fly. He's got to drive across the country. The truth is that if we really wanted to do this as a national project, and this is not a Better Place, but the Obama administration decided that electrification of transportation has all of these advantages, and we're not going to even allow one company to do it. The federal government's going to take this on as a project. You could do it very rapidly, because we have in this country, just as was talked about in the cell phone industry, about 40 major metropolitan areas that if they were done in parallel could be done in just a couple of years. And all that's left after that is putting these battery switch stations, which are not an enormous investment, at intervals along the expressways that connect the cities. And in fact, if you think about the East Coast or West Coast, 1,500 miles, New York to Miami, or Portland to Seattle to San Diego, if you were to put switch stations at intervals of 30 miles along those arteries, the entire investment for either coast would just be $25 million. It's 50 stations at about $500,000 apiece. So this could be done very quickly. Now, in terms of very, very rural areas, as Michael said, we still have problems with the grid itself in some of those areas, but that's not where most of the oil is being used. It's being used by people who live in these 40, 50 mile radius around these 40 metropolitan areas, and then along those expressways. So the infrastructure build out need not be that daunting. And by the way, the total cost is about 6 months worth of imported oil.
I would just add to that also, where there's a will, there's a way. I mean, think about the internet. The amount of infrastructure that's been built up in the last 10 to 15 years is just extraordinary. And, the number of cell towers that now dot the landscape. When people, the consumer wants something and the value proposition is there, the investment will be made. And I'm just reminded of something from a sort of a different sector. But now that the little compact fluorescent light bulbs have become so popular, you may have noticed that all the incandescent manufacturers are doubling the life on their bulbs. And basically, for 75 years, we've been taught, well, that's it on the incandescent bulbs. But once there's a little competition out there, we find that they're actually able to get a lot more life out of the incandescent bulbs. So if the incentives are aligned correctly and if the demand is there, I think the economy can adjust. So with that, I just want to say thank you to everybody. This has been a very interesting panel for me. Thank you, our panelists, for coming here to Washington. There have been a number of very interesting proposals mentioned. Mike's proposal about a charge infrastructure is something that I don't think has received the sort of attention that it deserves here in Washington. Just a lot of interesting food for thought. And again, thank you, everybody. And we look forward to continuing this dialogue with you going forward. Thanks very much.
Thank you.